Yes, ready to go. Perfect. Thank you. Thanks, everyone. Yeah, so my name is Yawar, and I will talk a little bit about ReasonML, which is this great new language syntax, rather, from a few people at Facebook. They're working really hard on it. So I just wanted to kind of show it off a little bit because I think it's really cool. And so ReasonML is it's basically OCaml. It's the same language as OCaml, exactly the same thing. Just that they put a new syntax, like a new skin, on top of the old OCaml syntax. They got rid of the old syntax and they put in a new syntax. And this new syntax looks basically like JavaScript as much as possible. Sorry, I'm just going to. Actually, I messed up because I should have separated my displays so that I could keep my notes here. But anyway. Okay, sorry. I'm just going to actually bring this there. Much better. Yeah, so, and keep my notes for myself. Yes. Yeah, so it's a JavaScript-like syntax, and they basically got every single OCaml syntax feature that exists, and they did a straightforward one-to-one mapping between OCaml syntax and Reason syntax. And what they did was they got rid of a few ambiguous corner cases from OCaml, and they simplified a few things. They made it a bit more comfortable for mainstream people coming from other mainstream languages. You know, they added parentheses and all that stuff because people often get confused in functional programming languages. Like, oh, you don't have any parentheses? So how do I pass in arguments? Like, how do I, you know, all that sort of stuff. And so they just said, let's get rid of that confusion from the very beginning. We'll bring back parentheses. We'll bring back semicolons. The syntax will be completely regular, and it's going to be really easy to use. So that was the main idea. So they did that, and they got great tooling. They built on this base of using the BuckleScript compiler, which is this amazing OCaml to JavaScript compiler from Bloomberg. Bob Zhang at Bloomberg is working on it. He has a team. He's working on it, and so what it does is it produces really amazingly optimized JavaScript, and I'll show you guys examples as we go on. And on top of that, they built in really great editor support. They're primarily targeting Visual Studio Code right now, but they also have great support for Atom and some support for Emacs and a little bit less for Vim, I think. But if you use VS Code, you'll get an amazing experience for sure, because I am using it for a while, and very few problems, especially compared to my experiences with other editors and IDEs. So for sure, it's great, and you have full type support. They do conversions. They have a auto formatting tool just like GoFMT. They have automatic syntax upgrades. So when they make slight adjustments in the future to the syntax, you automatically get it, but just by running this one script that they give you. And yeah, no problem. Great community. We usually hang out on the Discord or on Twitter. You can get all the links from the website, and yeah, I definitely want to, if you check it out, and I'm sure that if you have questions, people will be really helpful. Windows support is a little bit behind right now. We are heavily relying on WSL, Windows Subsystem for Linux, and that's only available in the Windows 10 Creators Update version, so it's really kind of cutting edge right now. So, and you have to kind of manipulate a few things more than you do in the other OSs, but it's a work in progress. So I think we will have good news and better news on this pretty soon. So let's have a look at some code. There's traditional OCaml on the left, and the Reason syntax on the right. And as you can tell, this is a person module. It just defines a type, kind of like a class, and it's some associated operations. You have a constructor, make. That's just a convention. It's not a requirement to call it make. So you make a person with an ID and a name, and you can greet a person by taking the person record. The type T is a record. And you can convert the record into a string output. T, we're using T because that's the traditional type name that you use for the main type in an OCaml module. So from outside of this module, you're going to refer to this type T as person.t, and it doesn't make any, OCaml versus Reason syntax doesn't make any difference. The semantics are exactly the same. In OCaml, traditionally, you export every single thing that you define in a module, so it will all be visible from outside or other modules. So they won't even have to do any imports. They can just directly start using person.t, person.make, person.greet. OCaml automatically resolves all the module uses. So yeah, this talk, I want to focus on really the type system that OCaml and ReasonML brings to the table, because it's something I think that's really unique among many different JavaScript compilers, transpilers that you have out there. Of course, there are pretty powerful languages out there today, but I think OCaml brings a pretty nice and elegant system into the mix. So let's have a look. So the basic idea with the basic way I've organized the type slides is that I think of slide types as being put into kind of buckets, various buckets, and these buckets let you use different kind of techniques, optimization techniques or safety techniques and things like that. And I'll show you what I mean in just a sec. But another important point to remember is that every single type, the whole type system, everything is totally and completely erased when you compile to JavaScript. So the JavaScript outputs will be absolutely dynamic, but they will still be correct up to the extent that you were type safe in the original Reason source code. So a few of the type buckets are, these are the main ones that I'm going to talk about. There are others, obviously, but right now, these buckets are usually the most important in most code. So you have product types, sometimes parameterized types, generics, which people call generics, function types, and abstract types. I'll go through each of them. There's a lot of other techniques out there, but these are kind of like the workhorse techniques in the OCaml ReasonML world. So when you are doing day-to-day programming, you're going to be basically using all these buckets. So from here, we're getting to the interesting stuff. So first of all, I'm going to tackle product types, which package values together. So really what this is saying is that you need, if you are going to have a person, and I'll just get to the different options in just a sec. The basic idea is that, I want to have a person type, and the person type has to have an ID and a name. And so the person type, what is it made up of? How do I make it up? How do I compose together simple types into more complex types? So you have many different options, several different options. ReasonML, if you're targeting JavaScript, supports all of the normal OCaml product types, which are tuples, which are just the same thing that you will know from probably Python, or we use arrays in JavaScript to express the same thing. Many languages have tuples. They're just like bags of types that you put together in parentheses. Basically, that's the main idea. Or you can do a record type, which is kind of like a C struct. The advantage is that you have field names for the records, and so they have a nice way of acting as documentation as well. And here's a couple of more interesting product types, which Reason supports. The first is the object type, and the object support comes from the fact that OCaml and ReasonML are both completely object-oriented languages. OCaml stands for Objective Camel, of course, and the fact that they are completely object-oriented means that they support, inheritance, runtime dispatch, all the good stuff. So if you want, you can program in that style, no problem. We don't usually, because we reach for other stuff in OCaml first, Reason first, because they're just a bit more powerful than normal OOP, but we'll come to that in just a bit. And there is one last product type in Reason and in BuckleScript, the compiler makes available to you, is the JavaScript object type. which literally just compiles down into JavaScript objects. So if you are doing interop work, this is really great because the JavaScript objects interop absolutely flawlessly, seamlessly with the normal JavaScript world. And the syntax difference, you'll see there's a little dot in front of the left brace. That indicates that it's an object rather than just a tuple or record, or record rather. And the reason syntax for differentiating between OCaml traditional objects and JavaScript objects is that you put double quotes, you surround the field names with double quotes, just like you might do in JavaScript objects, actually. Well, we might use single quotes, but in Reason, we use double quotes for strings, yeah. Are there semantic differences between the normal object and the JS object? Yeah, there definitely are. The normal OCaml object is a bit more heavyweight, and what the BuckleScript team was able to do with JavaScript objects that you see here is that they were able to directly map these this particular type, this JavaScript object type, into straightforward JavaScript objects. They got rid of all of the, they don't need any runtime support. They don't need any translations back and forth between the JavaScript and the OCaml worlds. So it's a very nice syntactic convenience and also a semantic convenience for sure.
So the cost is that you have fewer features with the JavaScript world?
The cost is you have fewer features in the JavaScript object. I wouldn't really, maybe, actually, I don't see, I haven't experienced any loss of power, to be honest, because you can actually use everything because if you can't use one particular thing, then you can do another thing, which BuckleScript provides very powerful binding system, foreign function interface to JavaScript functions and types and objects, and you can just go and pretty much do whatever you like because the BuckleScript system is so expressive and permissive that you can basically just do whatever you like. But usually, just compile all the objects to JS objects because, yeah, that's a good question. Yeah, actually, in BuckleScript, the thing is that the BuckleScript is a full-fledged OCaml compiler to JavaScript. So it supports 100% of OCaml. The team might know a few more details that I don't, but as far as I know, it supports 100% of OCaml and adds on a little bit on top, which is the JavaScript stuff. But when when you're supporting 100% of OCaml, that includes the traditional OCaml objects. I guess it makes it easier to port over your code between different targets, compilation targets, and so they do support it. So, but normally we would actually stick to JavaScript objects when we are targeting the JavaScript ecosystem. Yeah. So actually, let me do some interesting stuff now, which is I'm going to run this code. If I can. Oh, right, need to exit the presentation mode. I'll just keep it like this, I guess, because I need to copy paste stuff. So let's actually run this code and see what happens. The output is going to appear on the right. If I compiled correctly, yeah. Oh, okay. Actually, I actually got fooled by BuckleScript for a second. It actually compiled it just now as soon as I saved, and it output nothing because it erased all the types. So as you can see, when you define types, the output is nothing in JavaScript. So that's what. And it's so fast that you're going to miss it if you blink. That's the one thing, something I forgot to mention. So let's look at let's examine the OCaml object system a little bit more carefully, closely, because I think it's really interesting. And note that you get a lot of these advantages in OCaml in the JavaScript object functionality as well. But I'll just go through this. The traditional OCaml objects just now. So the object system is really cool because they let you pull out objects out of thin air in the sense that you don't need to define the type first. You can just literally say that I have this value that I'm getting in my function greet. I'm getting a person value, and I'm going to do some call these methods person hash name and person hash ID on the object that I'm getting. And I want you, the compiler, to make sure that the methods that I'm calling line up with what this function will get at runtime. So whoever calls this function must provide an object which supports at least the name and the person and the ID methods. And they can provide any other methods they like, but they have to support at least the name and the ID. And then this will compile. So the compiler lines everything up for you. This is just like duck typing, where you're just asking your whatever object you get for this value or that property, but it's all just resolved at compile time. It won't compile unless you use it correctly. And so this is used to really good effect in the JavaScript interop, because we often get a lot of different objects and we send objects between to and fro, and we use them and we use this kind of type discipline to make sure that we don't mess up, basically. And if you see the ... in front of the type annotation, VS Code will kind of show you a really cool type annotation just on top of every single object or value or type that you define, and it looks kind of like that. And it's automatic. You don't need to do anything special. The object is what's known as an open type, which means that it supports at least the ID and the name methods and other stuff as well, possibly, but not necessarily. So that's an open type.
And is this greet method one that will work with records, objects, and JS objects?
OK. This greet function will work only on types which match that exact shape, which is an OCaml open object which has the ID and the name methods. And that's it. It won't work with records or tuples or JS objects. No, yes, JS objects, correct. But interesting.
Won't work with OCaml objects that aren't open?
It will work with, I'm pretty sure it will work with OCaml objects that have only the ID and name methods, but it won't work with anything that has only an ID or only a name method. It has to have both of these. So let's actually try it out, because I might be able to answer some more questions better by just compiling the code and seeing what happens. OK. So that's the compile output. And so the JavaScript function greet returns the string, which is kind of OCaml. BuckleScript has some auto-currying functionality, which it uses to make sure all the function calls are lined up properly, because OCaml has this, Reason has this property of automatically currying every single function. So BuckleScript has to kind of do a little bit of a runtime translation there. But the basic idea is that it calls out to person ID with this function call, person.id, and it gets person.name with that function call. Is that sorry?
I said, is that a genset? Is that just a random integer that's?
Oh yeah, it's a generated integer which represents the ID method, and the other one represents the name method. So they just automatically generate the corresponding integers.
If you recompile it, will it be different integers the next time?
I'm pretty sure it'll be the same, because
So they're using some kind of hash function?
they probably hash from the method name to the string, output string. So let's actually look at what happens if we change this to become a JavaScript object. And the only difference we need to do is that we use this BuckleScript supported hash syntax for JavaScript object method calls. Let's look at what happens. So function greet person return hello plus person.name plus with ID string of int of person.id. And all of the runtime translation stuff is gone, and you're using just the JavaScript directly, the JavaScript objects, person.name and person.id. And OCaml likes to make sure the types are really explicit, so it converts string to int, int to string, to make sure that you can legally add together all the strings, and you don't try to add a string and an int.
You
Yes, actually, I had to do this, otherwise it wouldn't compile. Yeah. If I get rid of this, you'll see a compile error, or you won't hear, but I'll see it in the terminal over here. So anyway, yeah, so that's basically, this is the convenience of BuckleScript's JavaScript support. With just with this hash, it turns into really simple JavaScript output. And again, no types anywhere. All the types are totally inferred. I'm sorry, I don't have my editor support set up properly. Otherwise, I would have showed you the really awesome type inference and type hints and annotations and stuff like that. But anyway, you can definitely check it out. OK, so let's have a look at the next bucket, which is sum types. And sum types are, the name comes in the sense that all the possible values of any particular sum type is the set of the sum of all the possible values of the constituent types. So it's kind of type algebra, but that's where the name comes from. But the basic idea is that they express the idea that you can choose between this type or that type or that type or that set of types and so on and so forth. So any particular type, for example, the shape type, can be one or two or many different possible alternatives. So you can actually have a direct one-to-one correspondence from OOP class hierarchies to sum types, because in OOP, the way you would express this is that you would say that you have a interface shape and you have a class rect, which implements shape with length and width methods, and you would have a class circle, which implements shape with the radius method. But instead, over here, you just directly write down the alternatives and you create the sum type. And these length, width, radius are just type aliases. They're not anything special. They're just for documentation purposes. We want to say that a rect has a length and a width, and a circle has a radius, but they're really just floats, and they're transparently floats. This is simply so that the reader can understand a little bit easier and faster what exactly these things are. Otherwise, you'd have rect, float, float, and circle, float. So that's not very understandable. OK, so with this, we can make a function area which accepts a shape and immediately deconstructs it, just like in JavaScript destructuring. It destructures it into either the rect or the circle object, subtypes, rather, or data. And it automatically extracts the length and width or the radius and calculates the area based on those auto-extracted values. And all of this happens for free. The rect and circle are you can basically think of them as runtime tags, which indicate what exactly it is. And it carries that information around with it at runtime. And when you match on it in the function, it actually checks at runtime what it actually is, and then it decides which branch to follow. And this stuff is compiled into switch statements. Actually, right now, if I show you this example, you'll see that BuckleScript will compile it into a if-else branch, because I just have two cases right now. But if I added another case, then you would see a switch, because then you have more than two. So if param.tag, and the first tag is 0 for rect, then it returns, 0 for circle, rather. And then it gets the radius of the circle, and it does the circle area calculation. Otherwise, if param.tag is not 0, in which case it's 1, which means rect, it grabs the length and width and gets the area. OK, so that's, yeah.
Rect and circle in this context, do they mean anything special? Are they some classes defined?
Oh, do rect and circle mean anything special? They're just type tags. You can think of them as tags on the runtime types.
How do you use
Yeah, absolutely. In fact, I can do that right now. Let's call it rectangle, right?
It's just a way of marking these types.
Exactly. It's literally you make up a name and you set it to whatever you like. And so I renamed that thing. And so now it tells me that there's a type error. And there's no constructor called rectangle because I didn't define it beforehand. So let's define it and see what happens. And it finished. It looks like that error is still there, but it actually finished without errors right now. And it did not actually change the output code at all because the name itself doesn't matter to the JavaScript output. All that matters is the tag, which is a numerical value that it compiles down to, 0 or 1. OK, let's go back to sum types. Yeah.
Is there a difference between, I say multiplication and a dot?
Yeah, that's a good question. Is there a difference between normal multiplication and multiplication with this dot? So Reason is and OCaml are very, very particular about trying to do operations on different types of values. And so they have different operation symbols for float multiplication. For float multiplication, you have to do star dot, float division, star slash dot, and so on and so forth. For int, multiplication, division, addition, arithmetic, all that stuff, it's just the normal ones without the dot. Plus minus, star, slash, they're corresponding with the dot for float. So that's kind of a, some people get annoyed at that, like why do I have to have different symbols for just the same numerical types with just a little bit of difference there. But OCaml is very particular about keeping them very separate. You don't want to accidentally mix up floats and ints, and it won't let you. You have to explicitly do conversions.
What range are integers?
Integers are, OCaml integers are, I believe, 31-bit. So what is it? Minus 2 to the power 31 to...
Any built-in support for big numbers?
There is a big num module in the standard library, I believe. I'll have to check. But if not, there are a bunch of libraries available. And worst case scenario, which is not really that bad, is it's really easy to write ReasonML bindings to existing JavaScript libraries. The FFI is really nice. Yeah. So let's look at what OCaml Reason calls polymorphic variants, which are, again, sum types, but you make them up just on the spot without even having to declare them beforehand. So we declared shape beforehand, but polymorphic variants, we don't need to declare beforehand. So with normal variants, you want to express, you express, I want to handle exactly these cases that I tell you about. But with polymorphic variants, you can say that, oh, I want to handle at least these cases, or I want to handle at most those cases, or I want to handle some of those cases plus these other cases that I just tell you about. So it's very flexible. So you have to be a bit more disciplined, but it's definitely a lot more flexible. So let's look at an example. This is actually really useful in the JavaScript interop world. They use it to good effect. But let's look at this example right now, which is we literally just make up a function area which takes these tags with backticks, which indicate that these are polymorphic variant tags, and instead of the normal variant tags. So the backtick says that, oh, you have a rect tag with a length and a width, and you just calculate the area with the star dot, and circle radius, circle has a radius, and you do the circle area operation. Triangle has a length and another length there, possibly length or whatever. We don't really care about it. We just need two of the lengths. And we're going to do the triangle area calculation. I hope I got that right. It's been a long time since high school geometry. And OCaml Reason automatically infers the type for you, the type of the function. It says that the type of this function is it's a polymorphic variant type which has at most circle float tag, a rect float tag, or a triangle float alpha tag. Alpha means that it doesn't actually know what the type is, so it just left it kind of generic. And it returns a float. Let's try it out and see what the compile output looks like. Note the last line is commented out. Slash star slash is the reason comment. But I will show you what happens when you uncomment it in just a sec. OK, so. Yeah. Oh, yeah, absolutely. Let's try that. Oh, okay. Okay, cool. That's much better. So polymorphic variants are more complex than normal variants for sure, and that's reflected in the JavaScript output, the lengths that Buckle script has to go to compile them. But really, all this is saying is that um, if this is a particular case, then do this. This is obviously the triangle case. Otherwise, do this, which is the rectangle case. Otherwise, this is the circle case. You can tell from the calculations. Let's actually take a look at what happens if we get rid of these comments. What actually happens is, and I wanted to show you, but unfortunately I forgot to set up the editor support, is that it will automatically infer type, and it will automatically change the type as soon as you put in this other catch-all case in the pattern matching expression. And it changes the type, and it says that, oh, I can handle anything else here. And it actually does handle that final case by putting it in this branch over here. So it does a lot of nested ifs to handle all the different possible cases. So it doesn't lose anything in the translation. It makes sure that it considers every single possible case. So polymorphic variants, again, no type definitions anywhere in sight. Everything is automatically inferred just by usage. And yeah, these are really interesting because they're used a lot in the JavaScript interrupt world in Reason. Yeah, so now getting to really interesting stuff. Parameterized types, which I promised you guys, is basically generics. But what well, I'll talk about the some of the techniques. But what these basically say in the Reason type system is that we're giving you this type, whatever, and we'll put in another type later, which will make it a complete type. But for now, just trust us that you're going to get other types, which will make this a complete type. So for example, here's a really simplest possible example, which is the identity parametric type, which is that you have a type which takes a type parameter alpha, and which is just actually alpha itself. Notice how it looks kind of like a function, kind of. It's basically a function which takes a type parameter, a function at the type level, which takes a type parameter alpha and just returns the alpha value itself. So we call it identity. And it just means that the type identity of alpha, or identity of whatever, is just the type itself, whatever you pass in. This is useful in certain cases where you use higher kind of types and monads and stuff like that, but probably not in the everyday case. But it's just an interesting thing that falls out of the parameterized type system. So the really useful day-to-day stuff that you will come across is things like list, which is just your normal linked list, singly linked list, which in OCaml is expressed as saying that it's a cons of an item and a list of items, or it's just an empty list, nil. And so notice how this is a sum type, a variant type. In OOP, you would say that you have a list interface and a con subtype and a nil subtype. And so this corresponds to that. Another technique that you get is that you can kind of take advantage of is that you can tag any type that you already have. You can just tag it with another type. And this allows you to keep many different instances of your types completely statically separate from each other. So for example, you can say that I have an ID tag, which I will use to ID people, businesses, companies, whatever, addresses, and many different types of IDs. And I don't want to mix them up because I don't want to, for example, have a person ID and pull a business, be able to pass it to a business and try to get a business. Maybe. There are other cases where you might be able to use this. But anyway, what this is saying is that in Reason, the pry keyword means that this is a privately an int, but publicly we expose that this is an opaque type, but privately it's really an int. Shh, don't tell anyone. That's basically what this is saying. And yeah, there's many other use cases. One of the really cool ones that I like that I didn't have space for here is handling straight transitions properly. So you can do stuff like you can say that an open door cannot be opened again, closed door cannot be closed again, only an open door can be closed, and only a closed door can be opened. Stuff like that. It's illegal. It won't compile to try to do any of those illegal operations. So it's really, you can express a lot of safety conditions using that. Okay, so I'll just quickly look at function types because obviously everyone knows functions. This is functional programming. So I won't go into too much detail, but functions at the very basic level are saying that I have an input, I can give you an output O. So when it really gets interesting is when you have polymorphic functions which express that you can do an operation on potentially any type alpha. If suppose you have a type 2 string of alpha, which takes an alpha and gives you like a string. Which this is saying that you have the potentiality to do an two-string operation on any given type. But when you actually implement it with, say, example, person to string, that actually makes it a reality that you can kind of do that. You can for sure do that two-string operation. And so, the reasoning, the reason I show this is because then you can kind of talk about a higher abstraction in these cases and say that I'm going to pass around two string of alpha values. I don't care of what the alpha is exactly. All I care is that I'll be able to pass in some alpha value at some time and I'll get back a string. So it lets you think at a higher level. And speaking of higher levels, a really cool OCaml feature is the reason feature also is the module system. And the module system is pretty powerful. They let you, as I mentioned before, you can, by default, everything in a module is exported automatically. But if you want to hide stuff, if you want to keep stuff from leaking out, your implementation from leaking out to the world public, then you can use what's called an interface file. So for example, this .rei file is an interface file. And the person type that I showed you guys earlier might have an interface like this that you provide to your users. They're basically like C header files. And so when you provide this interface, you tell the users that I'm just going to give you this type T, which is the person.t, and you can construct values of T with an ID and a name. And you can get back the ID and you can get back the name. And that's all I'm going to allow you to do. I'm not going to allow you to do anything else, like toString or equals or whatever. And if you do want to allow that stuff, you can provide operations and stuff like that. So it's really powerful because you can change your implementation details under the hood. Like I just showed before that you have all of these different possible person types. The product types, these are all of the different ways that you could implement the type T. But to the user, all you have to say is that it's the type T. That's it. And when you change your stuff behind the scenes, they don't need to care. They continue using the interface. They don't even need to recompile. Yeah. Oh, yeah, back. Yeah. Yes, tilde. Yes. What does the tilde mean? Tilde means that this is a named parameter. So you can pass in parameters and tilde ID equal to whatever the value is at when you call the function. So really nice convenience feature. I just put this in just to show it off a little bit. So when you call the function make, you will say make open paren tilde name equal to tilde ID equal to 1, tilde name equal to Bob, for example, or you could actually swap them around and put them in any order. So the labels make sure, the names make sure that you cannot get the orders mixed up and stuff like that. Yeah.
So once you have this person array, this functions as C header.
Yeah, this is the C header.
And you would still have the person.rp where you implement.
Yes, you implement it.
Everything is inside the second file.
Yes. Yes.
Hidden.
Absolutely. Everything inside the implementation file, the .re file, is hidden away from the outside world.
Once you remove this file,
Yeah.
the other file becomes public.
Yes. If you delete the interface file, then the implementation file will become completely public. Yeah. So it's kind of like a mask that you put over your implementation, and it hides whatever you don't want to show off, and it shows off whatever you want to show. So yeah. And a final really cool technique that I want to show off is just paying zero cost for abstracting between types out safely. So what we're doing here is we're saying that we have a module ID, which is going to provide a type T. When you see module ID colon open brace, this is saying that the stuff between the braces is actually the type of the module. And the type of a module is exactly the same thing as an interface, except that you're expressing it now syntactically instead of at the file level, as you were before in an interface file. So syntactically, you're expressing the same thing, that you have a type T, but here we're exposing a little bit more than we were previously. We're saying that this is a private int. Privately, this is an int, and you can safely convert T values to ints, but we're not going to let you make T values by yourself. We're going to keep them private. And you provide an external function, which is a kind of like a special binding that says that if you give me an int, I will give you back a T, and it's the identity function. So OCaml Reason support this really cool thing where you can directly cast between types if you know that they have the exact same representation under the hood. You don't expose the implementation, and Reason won't let you mix up values of different types of implementation, but you can still say that I'm going to allow casting. So let's try it out. If I can find my mouse cursor. Yeah. Okay, so compile this. Let's see what happens. That's it. That's really all it compiles to. Literally compiles to var. Oh, sorry. It doesn't actually compile anything else because modules get erased, just like types. So at runtime, the only thing that you're going to see is actually functions and values that you defined. So let's actually define a value and see what happens. And you get the corresponding output, var result equal to 4. It erased the id.t type at runtime, and it compiled it down to just the number 4. And this is going to be done in a completely type-safe way. So for example, if you want to do let is 4 equal to result double equals 4. Double equals is testing for physical equality. Let's see what happens. Oops, output did not change. Why? Because there's a type error. So this is an int, the number 4, but result is an id.t type, and you cannot compare them for equality because they're different types. So in Java Scala, you would be able to get away with doing this kind of thing, but in OCaml, in Reason, even if you know that it's really the same thing as an int, you cannot do it. But if you say that, OK, just go ahead and do it because I know what I'm talking about, I'm going to cast it to an int right now, then it will allow you to compile. This is kind of casting it to an int. It's basically, think of it as like saying, result, go to int. And it compiles it to var is 4 equal to, and buckle script represents OCaml booleans as 1s and 0s. And you have to, it's kind of an artifact. They're working on changing it to just JavaScript boolean values. But in the future, you're going to see this literally true over there. But yeah, is 4 is true, and result is 4. Yeah.
Can you explain a little bit about this identity and
Oh.
double quotes and this person?
Double quotes. Ah, yes. So what is this identity stuff in double quotes? This means that this is a special way of expressing in OCaml Reason that this is a binding, what we call a binding. It's not a string. It's not a string. It's kind of, if you've ever done CFFI, it kind of looks like you just declare a value and you declare that it has a type, and then you say that that thing that I just declared is equal to, and you give a special symbol or a special tag so that the compiler knows that you're talking about FFI right now. So this is really FFI. And it's saying that this offInt function that I'm declaring is forcing the compiler to internally convert from an int to t, but like without actually allocating or changing any values. So this is zero allocation. And if you want, you can definitely implement it in a more traditional OCaml way. I just wanted to show off a little bit, so I did something, really a little bit out of the way. Most people would just do this. Yes, of int. Int. That's just a value. That's the name of the argument is equal to int, and I'm just returning it because privately it really is an int. So I'm just returning that, and it compiles it down to just functions. $$int. It just mangles the name a little bit. It tries to avoid mangling as much as possible, but it had to in this case because int is, I think, a reserved keyword in JavaScript or something like that. I'm not sure. And it just returns an $int, $int itself. So there's a little bit of function call overhead from this conversion. But if you want to totally get rid of all function call overhead, then you just do an external binding to the identity special symbol. And then all of that stuff is just compiled away. And you have type safety, but you don't actually pay for anything for it. You don't do any allocations. You don't do anything. You don't even do any function calls. Nothing gets on the stack. So, yeah.
Go back to the code.
Oh, yeah.
Do
Yeah.
you need to give PRI int or can you give type E?
Actually, you don't need to even expose the fact that this is privately an integer. You can just say it's type T. And it's going to be a compiler because I tried to cast it to int. I've tried to force a cast to int. But now I no longer expose the fact that it is an int. So I cannot cast it to int. I just cannot do that. But so now if I want to be able to convert it to an int, I have to very explicitly say that this actually, I will give you a function which you can use to convert to int. So you're not allowed to do it yourself, but I will give you a function that lets you do it. So instead of doing result cast int, you do id.toInt of result. And it compiles, yes, successfully to, there's a toInt function, and it compiles a result is 4 to true. And buckle script here is actually optimizing away the comparison, and because it knows what the result will be, and it's just directly putting the result there in the JavaScript. So it's highly, highly optimized JavaScript. This is the kind of optimizations that you're going to see in ReasonML buckle script output JavaScript. It's smart enough to know that this is always going to be true. And it also marks your function, your module, your JavaScript output module, saying that this is a pure module. There's no side effects. And tools like Webpack Rollup, bundlers, they're actually trying to figure out ways in which they can more efficiently do dead code tree shaking on pure modules because they don't have to worry about side effects. So if buckle script knows that there are no side effects and it can somehow tell the bundler, then the bundler can actually take advantage of that information. Yeah. Yeah. Yeah, it's really, I should have called it something else. Let's say we call it n, right? It's just a name. Yeah. And so is the t down here. That's just the name of the value, separate from the name of the type. Yeah. Yeah. So yeah, that's really some of the techniques that you can do in OCaml Reason to keep type safety, but at the same time, to really squeeze performance out if you want. So yeah, this is really just the beginning because there's a lot of work going on. The community is really active. Go to if you follow along with the Reason website, they have really exciting stuff going on. Check out the blog. Half of Facebook Messenger web app is written in ReasonML, and they cut down their bugs to like a few bugs a year, from a few bugs a month, something like that. I don't want to say day. And they have really amazing bindings to the React library, React.js. And Reason React uses the type system really elegantly. Just yesterday, they released a router binding, which is really cool because it uses pattern matching to destructure the route and automatically capture the parameters in the route without you needing to do anything special. And it just makes them available to you for out of the pattern match directly. So they're doing stuff like that with the type system. And they really believe that, that's the philosophy. Let's be pragmatic, but let's take advantage of the type system as much as possible. Yeah. So I think it's really cool. Cool, thank you.
Question.
Yeah.
Like, I was actually want to ask about React Native. So,
Yeah.
Reason React,
Yeah.
does heavy development for React Native or Reason?
Is there development on React Native in Reason? Yes. People are writing bindings and actually writing apps. There's definitely apps out there right now written in Reason React deployed to native. Plus, there's also stuff written in Reason compiled to native binaries without the JavaScript bridge of React Native, like literally using OCaml's native compilation. OCaml can compile directly to native binaries, and people have deployed to iOS using that compilation. Yeah. Is it possible to have runtime errors? Yes, absolutely. The type system is sound, which means that it guarantees that if the compile succeeds, then you won't get runtime errors. But there are a couple of escape hatches, including the FFI layer, and a couple of other things like polymorphic comparison, the double equal operator. If you try to compare two functions to each other, you'll get a runtime error because OCaml reason they can't figure out that functions cannot be compared because of the closure environments and stuff like that until runtime. So they make a bit of a, essentially the double equal operator has the type alpha arrow bool, but that's a bit of a lie because it can't really compare functions. So you have to be a little bit careful about that stuff. And the FFI, you have to be careful, you have to know what you're doing, but it's fairly easy and easy to get started. Yeah. Yeah. There can be, sorry? Ambiguity in the types? In the definition of the function. Yeah, for sure. So for example, you can define a type person equal to ID has type int, name has substring, and then you define another type right after that saying type person2 equal to ID has type int and name has substring, and then you put a function after that saying that this function takes an ID and returns the whatever, and you were expecting it to work on the first type that you defined, person type, but it will pick the second person type you defined because it comes second. But there are ways to keep things separate using the module system. There's definitely easy ways to avoid those clashes. Yeah. Yeah. Yeah.
You showed that the buckle-script compiler. Does that mean
Yeah.
that you can directly call buckle-script code in Reason?
Oh, yeah. Can you call buckle script code from Reason and vice versa? Yes, absolutely. There's first-class support for both syntaxes in every single buckle script project. So if you're targeting JavaScript, you don't need to care about who's written which libraries and which syntax. You can use any library, any binding, and write in your favorite syntax, OCaml or Reason. And everything will just work.
Do I need to know buckle script in order to write in Reason?
Do you need to know BuckleScript in order to write in ReasonML? You do need to know a little bit of BuckleScript if you're targeting JavaScript because there are certain JavaScript-specific things that BuckleScript does, like the FFI the JavaScript object type that I showed earlier. So some of those things, the more you know, the better, but you can get started really easily. And also the community's there, it's great, it's growing. There are manuals, the manual is really great.
Are there any other targets for ReasonML?
Yes, there is. ReasonML targets the same stuff that OCaml does, which is OCaml bytecode and OCaml native. And OCaml native is just really efficient binaries for the platforms that it supports. And the OCaml runtime is really efficient because the garbage collector is really great. Like it does this tracing generational mark and sweep garbage collection thing where it's highly, highly tuned for functional style, where you have lots of short-lived values, and they clean them up really quickly, and you're able to go through them really fast. You don't need to worry about churn. So OCaml binaries, really efficient. OCaml reason, OCaml, the only thing that you might miss is if you're like doing parallel, if you're trying to do parallelism, it doesn't have built-in support for parallelism yet. You will have to use libraries and stuff like that. But concurrency support is great. You can use promises in JavaScript. You can use lightweight threads in OCaml native, Reason native. So concurrency is great. It's just that multi-core support is not there yet. We're expecting it any year now.
That's for the native.
Yeah, native parallelism. You'll have to kind of do processes and stuff like that manually, or use Jane Street's async parallel library, which I haven't used myself, but it's out there.
So, me, I missed this, but can you take any OCaml library and use it on BuckleScript or?
Great question. Can you take any OCaml library and use it in BuckleScript and vice versa? They have two different build systems. So the OCaml world and the BuckleScript world are kind of separate ecosystems right now. So you would have to kind of manually take that GitHub repo or the project repo and put in the proper build config file. BuckleScript has a config file. The OCaml native ecosystem has their own config format. And so you would have to do those kinds of things right now. But in the future, the Reason team is hoping to introduce a uniform, all-platform, unified build system for everything. And so they're working really hard on that.
Does it have a decent package manager?
The BuckleScript ReasonML JavaScript targeting ecosystem is just using NPM. Nothing new. Yeah.
For ReasonML itself?
Same thing. If you're targeting JavaScript, you stay inside the NPM ecosystem. You use NPM. If you're targeting native,
They are hosting OCaml code, ReasonML code.
Yeah.
NPM.
yes, you can host NPM code, ReasonML code inside NPM, just the same way that TypeScript has type definitions in NPM in the at type scope, and they put all their type definitions there. In the same way, you can just upload your ReasonML bindings, libraries, anything you want into NPM. Yeah, it's really well integrated, like well thought out. Yeah.
Are there any, like, obviously there are projects that are using this. Are
Yeah.
there any, like, specific projects that you know of that are good to learn from? Like, I like to, like,
Yeah.
this might be something next to an extension project.
Yeah.
Have total control over it.
Yeah.
Explore.
Yeah.
Usually when I'm learning something new,
Yeah.
I try to look at existing code just to see,
Yeah.
like, how did they
Yeah.
follow certain things.
So any existing code to learn from, I would say look at the Seattle JS conference app. They have this meetup in Seattle JS, and they built an app for it, mobile, and they did really cool stuff there. They compiled to native, and they also have isomorphic a JavaScript component there as well. And so I think it's got everything together. So if you examine that app, it's really cool. Reason the website, they also have great examples. They have implemented, to-do MVC, Hacker News in ReasonML and stuff like that. So it's all good to examine that stuff, for sure. Yeah. Yeah.
So if I have a JavaScript library,
Yeah.
after responding interface library
Yeah.
that hide it and capture JavaScript,
Yeah.
is that how it works?
So yeah, if you have a JavaScript library, you will have a ReasonML or BuckleScript binding definitions, and then you'll be able to interact with the JavaScript seamlessly, just through the boundary of the type definitions. So you write the type definitions in Reason, and you don't have to do any special stuff. Like you don't have to put in TypeScript you have .d.ts, you have to do all sorts of stuff. But in Reason, every single thing is just a normal module, OCaml module, Reason module. So it just lives all together inside your source/directory, under your source directory. Yeah. Mix and match, very permissive. Yeah. Yeah.
Any more questions? If not, Yawar, thanks for introducing all the exciting technology for the year. Thank you very much.
Thank you for having me. Thank you. Thanks for listening.